Second question we have a two-hinged parabolic arch is as shown in the figure below. Find support reactions as usual. Calculate normal thrust and radial shear at 10 meters from the right support. 10 meters from the right support. Draw PU. Draw bending moment diagram. That means you have to calculate maximum positive as well as maximum negative bending moments as well. Then draw the PU. Here we have figure. Two hinged parabolic arch, two hinges at either supports at the same elevation. The maximum height at the ground is 6 meters. Loaded with UDL of 30 kN only on the left hand side, left half of the two hinged parabolic arch. Okay. Here the horizontal span here is 40 meters between the two supports. Okay. Here the given data is span, horizontal span L is 40 meters, height maximum height below the ground is 6 meters, and load is uniformly distributed load of 30 kN over the left half span only, over the left half span only. So the same way we found out the support reactions in the previous problem, you are going to find out using equilibrium equations. Summation moment at A is 0. We will equate all the forces. What are the forces? 30 kN per meter into 20 meters. Half span is 20 meters. So 30 into 40 by 2 is 20 into 20 by 2, 20 square by 2. And what are the other forces? No other forces, only support reaction VB. VB is anti-clockwise positive. The load is clockwise negative. Okay. If we equate this one, VB is the unknown, we will find out VB is 150 kN. Then summation V is 0. So VA plus VB is total load 30 into 20 span. Okay. So VA is unknown, we found out VA 450 kN. Next we have equation for parabola. Y of x is equal to 4hx 4 yx into L minus x upon L square. You can call this y or h. So substitute y is 6, L is 40. We have an equation y of x is equal to 0.6x minus 0.015 x square. This is called this equation 1. Okay. Now draw this table with the headings, column name, section, origin, limits and moment. We have two sections over here. AC, we have made this into two sections, rather AC and DC. Okay, two sections, AC and DC, because we have load over here, we do not have load over here. Sections AC and DC, AC and DC. In section AC, I will measure moment from A, and in section DC, I will measure moment from B. Okay, so the origins are A and B respectively. The limits are also, this is 20 meters, 0 to 20 meters, this is 0 to 20 meters. If I say take a section in AC, measure x from A, and here measure x from B. So we have moment VA moment in the section AC is VA into x minus Wx square by 2. Substitute VA and W will get this equation 450x minus 30x square upon 2. The same way in section BC we have VB, H will not consider now, VB into distance x. So VB into x is 150, VB 150, VA is 450. Okay. Now after this, this equation, you know, H is equal to horizontal support reaction equation we have. This is integral of limits 0 to L capital M into y dx upon denominator integral 0 to L y square dx. Substitute all the values in first for section, for both the sections AC and DC. For AC you have limits 0 to 20. Moment is 450x minus 30x square upon 2 into y of x is this one, y of x into dx. Next, BC, section BC, integral limits 0 to 20 and capital M is 150x, y of x is 0.06x into minus 0.015 x square, y of x dx. Next, denominator integral 0 to L, capital L, it is 40 over here because we are considering the whole span 0 to 40 y square, y whole square into dx. If you simplify this one, you will get capital H is 500 kN. Also, you have a check for this. H is equal to W L square upon 16y. Substitute what is W? 30. L is 40 square upon 16y is y we have over here by 6 meters. Okay, we will get 500 kN. This is a check. Now, part B, coming to part B, normal thrust and radial shear we have to find out. At 10 meters from right hinge shear, it is asked calculate normal thrust and radial shear at 10 meters from right support. So, right support is B here. So, if you want this one, first we have to integrate or to find out theta, differentiate this one, not integrate, differentiate y with respect to x, dy by dx, you got this equation, dy by dx is 0.6 minus 3, 0.03 x. At what? 10 meters. So substitute x is equal to 10 meters, equal this to 0. You will get or equal this, you will get this to tan theta. Okay. dy by dx is nothing but tan theta. At x is equal to 10 meters, it is 0.3. Tan theta is 0.3. Again, we have theta is equal to tan inverse of 0.3, 16 degree, 41 minutes. For normal thrust, we have equation normal thrust is equal to h cos theta plus v sin theta. Substitute h is how much? 500 and t cos theta is 16 degree 41 minutes cos theta and v is vb. We have vb is nothing but 150. We have over here vb is 150. So substitute 150 sin theta. So you get normal thrust as 517 kilonewton. The same way for radial shear we have equation radial shear is equal to h sin theta minus v cos theta. H is 500, theta is 16 degree 41 minutes, v is 150. Substitute, we will get radial shear as minus 2.5 kilonewton. Okay. Now coming to the last part, find out bending moment at each and every point. So first we will find moment at C. From moment at A and C is anyhow 0. Moment at C, what are the force we can consider either to the left or to the right. I am going to consider to the right. VB into 20 meters, anti-clockwise positive. HB into clockwise, this is minus HB into 6 meters. We have 150 into 20 minus 500 into 6, that is 0. MC is 0, moment at C is 0. Next, to find out maximum positive bending moment. Maximum positive bending moment will be occurring in the span AC. So I am going to write an equation to find moment at any point x at a distance x from A. Okay, what are all the forces acting? VA into clockwise is positive since it is to the left of the section. See, VA into x minus HA into y of x minus W into x by 2. That's what I have written over here. Moment, I will call this section point E, VA into x minus HA into y of x minus W into x by 2. VA is 450, x as it is 500, HA is 500, W is 30. Substitute everything. Y of x is this equation, y of x. Substitute over here. And now you have got an equation. If you differentiate this equation with respect to x, you will get dm upon dx. 450 minus 500.6.03 x minus 5x cube. X square is x cube by 3. Right? 3 into 2 is 6. 30 upon 6 is 5. Now if you equate this equation to 0, then you will get at that point, actually you will find out x. At that point it will be maximum bending moment. So I have got x is 16.67. So find out moment at E, that is E is x is 16.67 meters. Okay, E is at 16.67 meters from the left support. Substitute x equal to 16.67 in this equation. 450 into 16.67 x, 500 into 0.6 into 16.67 x. Okay, the same. Continue. After solving this, you will find out ME as 6232 kilonewton meter. Maximum positive bending moment. Same way, find out maximum negative bending moment. Where you will get maximum negative bending moment? In the section BC, you will get maximum negative bending moment. Write an equation for that. Here on the right hand side of C, you do not have any forces, you have only support reactions VB and HB. VB into x horizontal distance, HB into y of x vertical distance. For y, substitute this equation. Okay. Then you have an equation. Differentiate this equation with respect to x. You've got one more equation. Solve this equation. You will find or equate this to 0. You will find x is equal to 10 meters. That means at a distance of 10 meters from the right side support, you will get maximum negative bending moment. Substitute this x is equal to 10 meters in this equation. You find m of f. X is equal to 10 meters from left support means I have considered this point as f. F is nothing but d. D earlier we found out radial shear and normal thrust at that point d. The same point. You get m of f or m of d is equal to 150 kilonewton meters. Maximum negative bending moment. This is maximum positive bending moment. Okay. Now draw the BMD. We have drawn the parabolic shape earlier. Then in this, the BMD below the UDL, you will get parabolic shape. I have written that. At point E, you will get maximum bending moment, that is positive bending moment, that is 60 to 32 kilonewton meter. At a distance of 16.67 meters. Here we have got 16.67 meters from point A. We will get maximum bending moment 60 to 32 kilonewton. At moment at C, we have got 0. Then moment at D, we have got maximum negative 150 kilonewton weight. And again moment at B and A, it is 0. This is the BMD.